Red line is here, higher temperature, greater kinetic energy, more collisions rate will be higher because active area in the right part increases. Welcome to the video rate of reaction. In this video, I want to discuss the following things. The simple explanation of rate of reaction, effect of concentration changes on the rate of reaction, Boltzmann distribution curve, and the catalysis. The first point, explanation of rate of reaction. Rate of reaction equal to amount of product produced divided by time taken. We can define this one alternative way. Rate of reaction equal to amount of reactant used divided by time taken. I want to give one example here. Calcium carbonate hydrochloric acid react. The product is carbon dioxide gaseous product. We are taking here in the gas series. In this case, we are taking time as well. So this is the curve. From here, the gradient is the rate of reaction. Another experimental explanation. I am taking here zinc and hydrochloric acid. Stopper is given with the cotton wool plug. When a reaction is occurring, hydrogen gas is going off. Here the mass will be decreased, and the time will the mass will decreases, and here the gradient is the rate of reaction. Concentration changes on the rate of reaction. This is very important factor for the rate of reaction. With increasing concentration, rate of reaction increases. Two main reasons. The first one is concentration increases means more particle in unit volume. So more collisions, more particle in the unit volume and more collisions. If you look here, lower concentration and higher concentration means the same volume but the more particles and the more collisions. As a result, rate increases. So I'm giving you one experiment here. I'm taking sodium thiosulfate solution. This is colorless solution, and we can see a cross mark taken on the bottom of the transparent glass beaker. And here we are adding hydrochloric acid. Hydrochloric acid react with the sodium thiosulfate, make sediment of sulfur. When sulfur sediment is coming there, we can't see the cross mark. And here, more concentrated hydrochloric acid, the cross mark disappear quickly. So less time is needed to complete the reaction. So here we can explain the concentration effect on the rate of reaction very easily. Boltzmann distribution curve, very important point for this topic. And here y-axis number of particles and the x-axis energy. This curve start from 0 and never cut x-axis. Here the peak point indicates here maximum number of particles, moderate amount of energy, and the right part have high energy, greater than activation energy or equal to activation energy, they can react easily. But left side have low energy, they can react. In presence of catalyst, the alternative pathway created and then new area, more particles can react now. Red line is here, higher temperature, greater kinetic energy, more collisions rate will be higher because active area in the right part increases. But the left side decreases. For the explanation is that peak is down and right. For lower temperature, peak will be off and left. In this case, the area, active area decreases and inactive area increases, but overall number of particles is the same. Catalysis. Catalyst creates an alternative path that has lower activation energy. It is chemically unchanged. If I see here in the diagram, the red line without catalyst, but the green line with catalyst, that alternative pathway, lower activation energy, the reaction will be faster. Catalysis are two types, homogeneous and heterogeneous. Homogeneous means catalyst and the reactant same phase, sulfur dioxide and oxygen gas. NO is also gas here, the same phase, so this is homogeneous catalysis. Catalyst and reactant different phase, that is the heterogeneous catalysis, sulfur dioxide and oxygen gas, but B2O5 is the solid, B2O5 is the catalyst here, vanadium 5 oxide. So different phase, this is heterogeneous catalysis. Enzymes are also catalysts. They are called biological catalysts. Enzymes are mainly globular protein, can be active sites. In the active sites, substrate can feed. When the substrate cannot feed, differentiate, no reaction. So in this case, enzyme plus substrate make complex. This is reversible reaction. But when the product is produced, the product cannot feed to the enzyme, the same active phase where the substrate can feed. So shape changes. So this is irreversible. If you have any specific question about this topic, you can write in the comment below. I think you will get the correct answer. If you get very little benefit from this video, please subscribe the channel and share with your friends. Thank you very much for watching this video.